Ever wondered why parking garages all feel kind of the same? Tight turns, slanted ramps, low ceilings. That's not bad design. It's math quietly doing its job. Today, we're breaking down how math determines the design of parking garages, and why every inch matters. The number one goal of a parking garage is simple: fit as many cars as possible into a limited space. Designers use geometry to decide stall width, length, and spacing. The average parking space is about 9 feet wide and 18 feet long, just enough for most vehicles, with almost no wasted space. Angles matter too. Straight-in parking uses less driving space, while angled parking uses trigonometry to make turning easier but takes more room. Every layout is a math trade-off between capacity and convenience. Ever notice how parking ramps aren't too steep? That's calculus and physics at work. Engineers calculate maximum slope percentages so cars can climb safely without scraping or losing traction. Too steep? Cars struggle. Too flat? The garage needs more space and costs more to build. Math also controls turning radiuses, making sure SUVs and trucks can navigate tight curves without hitting walls. A single car weighs around 4,000 pounds. Now multiply that by hundreds, sometimes thousands, of cars. Engineers use algebra and structural equations to calculate how much weight each level, beam, and column must support. They factor in vehicle weight, movement, vibration, and safety margins. That's why garages look solid and repetitive. The math demands consistency for strength. Ever notice one-way lanes and spiral ramps? That's optimization math in action. Designers model traffic flow to reduce backups, minimize accidents, and get cars in and out faster. Less stopping means less congestion, and fewer angry drivers. So, next time you park your car, remember, that garage wasn't designed by accident, it was designed by math. Like, subscribe and follow for more ways math secretly runs the world.